The most basic diagnostic tool available is ping. It's also the safest active tool for use in OT environments because it sends a minimal number of simple packets and waits for a response. If you've worked in networking at all, you've used it. Let's make sure you're using it deliberately, understanding both its diagnostic value and its security applications. Ping sends an ICMP echo request packet to a target IP address. ICMP, or Internet Control Message Protocol, is a network layer protocol used for diagnostic and control messages. An echo request is simply device is reachable, configured to respond to ICMP and not blocked by a firewall. It sends back an ICMP echo reply. Yes, I'm here. Ping reports three pieces of information: whether the destination is reachable at all, the reply is received or the request timed out, the round trip time in milliseconds for each reply, and whether any requests went unanswered, the packet loss percentage. That's it. Ping answers one specific question: is the device reachable from here right now? And how long does it take to get a response? It doesn't tell you what services the device is running, what ports are open, or anything about the device's state beyond network reachability. For many diagnostic purposes, that one piece of information is exactly what you need. The command is ping, followed by the IP address on Windows, Linux, and Mac OS. On Windows, ping sends 4 packets by default and stops. On Linux and Mac OS, it sends continuously until you press Control-C to stop. On a local area network, devices which are on the same subnet or adjacent subnets connected by a switch and router, a round trip time under 5 milliseconds is normal. A response time of 1 to 2 milliseconds typically indicates a device on the same network segment. A response time of 3 to 10 milliseconds might indicate a device across a router hop. Response times of tens or hundreds of milliseconds on a LAN might suggest network congestion or a device under heavy processing load, or a problem with a WAN link if the device is remote. Intermittent packet loss, where some requests are answered and some not, might point to an unstable network path, a faulty cable, a failing switch port, network congestion causing packet drops, or a device that's heavily loaded and deprioritizing ICMP responses. If you have 100% packet loss or no responses at all, this will mean one of 3 things: the device is offline or has failed, the network path between you and the device is broken, or the device or a firewall between you and it is configured to block ICMP. A PLC that's been configured to block ping might still be running its control program normally. The absence of a ping response doesn't confirm the device is down, only that it's not responding to ICMP. Ping's security applications go beyond basic connectivity testing. The simplest application is reachability verification after a firewall or a VLAN change. Did this change break connectivity to the device? Ping answers that immediately without having to wait for an application level failure to surface the problem. A device that should be reachable but isn't is worth investigating. A PLC that responded to ping yesterday and doesn't today may have faulted, lost power, lost network connectivity, or been physically removed from the network. The absence of a response is a signal that something changed, and changed things in OT environments are always worth examining. A device responding to ping that has no entry in your IP address inventory is an unauthorized device. Someone or something is on your network at that IP address, and you don't know what it is. This is a security finding that warrants immediate follow-up. Identify the device, determine how it got there, and decide whether it belongs. Automated scheduled pings to critical devices such as PLCs, SCADA servers, historian servers, and other key network infrastructure can provide basic uptime monitoring. If any of these devices goes offline, an automated alert generated by a failed ping can trigger a faster response than waiting for an operator to notice something is wrong in the control display. A ping sweep, which is sending a ping to every IP address in a subnet range to see which ones respond, is a way to discover which addresses have active devices without port scanning. Most devices respond to ping unless they're explicitly configured not to, making a ping sweep a useful first step in building an asset inventory. The ping sweep sends far fewer packets than a port scan and is much less likely to cause problems with sensitive OT devices. though the safety caveat from the previous video still applies on production networks. In the next video, we'll cover traceroute, which goes further than ping. Where ping tells you whether a destination is reachable, traceroute maps every hop the traffic takes to get there and shows you where latency is introduced. That's particularly useful for identifying unexpected devices in the network path or diagnosing where a performance problem is occurring.